Hcf and LCM. Well, one of the most important concepts of the number system if you are an engineer and trying to appear for placements. Because you take any placement paper, usually there will be at least 2 questions from Hcf and LCM. Well, for the other competitive exams, usually there will be 1 question on Hcf and LCM or sometimes none. Now, if you are preparing for the other competitive exams, then you might be thinking that you can skip this topic. Well, actually no. Why? Now, this is the topic which is gonna help you like anything when you're dealing with time and work and time, speed and distance. So when you deal with TSD and time and work, every problem can be solved using the concept of Hcf and LCM. So that you will learn when we are dealing with time, speed and distance and time and work. Now in this video, let us understand everything about Hcf and LCM. The very common definitions what students know about Hcf and LCM means, Hcf means highest common factor and LCM means lowest common multiple. Well, is that it? Not exactly. There is a lot more that we need to know about Hcf and LCM. Now, before going into Hcf and LCM, let us see what they are exactly depending on. Highest common factor, it means Hcf is all about the factors. Lowest common multiple means LCM is all about multiples. Now, let us understand what are factors and what are multiples. So, if I talk about factors, what are the factors of a given number? Suppose if I take 6, factors are 1, 2, 3, 4, 6. Sorry, not 4, 1, 2, 3, 6. Suppose if I talk about 10, 1, 2, 5, 10. Suppose if I talk about 12, 1, 2, 3, 4, 6, 12. Right? These are the factors. Now, what are factors doing? If you observe, 1, 2, 3 and 6 are factors of 6 only because these numbers can divide 6. Can I call 4 as a factor of 6? No. Why? 4 cannot divide 6 completely. Right? Likewise, 1 to 5 and 10 are factors of 10 because they can divide 10. 1, 2, 3, 4, 6, 12 are factors of 12 because they can divide 12. So what do you mean by factors of any given number? Factors of a number are those which can divide the given number. I am repeating. Factors of any given number are those numbers which can divide the given number completely. They are nothing but factors. Now let us talk about multiples. What are multiples? Now let us take the same numbers. If I talk about 6, 12, 18, 24, 30, 36, so on. These are multiples. If I talk about 10, 20, 30, 40, 50, so on. These are multiples of 10. 12, 24, 36, 48, so on. Now, why these are multiples of 6? Because these are divisible by 6. Likewise, these are divisible by 10. These are divisible by 12. Now, can I call 64 as a multiple of 12? No. Why? 64 is not completely divisible by 12. Now, suppose if I take 45, is it a multiple of 10? No, because 45 is not completely divisible by 10. So, what do you mean by multiples of any given number? Multiples of any given number are those numbers which are divisible by the given number. Factors of any given number are those numbers which can divide the given number. So, factor divides the number, whereas multiples are divisible by the given number. Now, another thing what you can observe here is factors are always a finite. There will be always finite number of factors. Whereas multiples are always infinite. You can write any number of multiples for any given number. So, factors are infinite, factors are finite and multiples are infinite. Now, understanding of the factors and multiples, now you can clearly understand what is the meaning of LCM and what is the meaning of HCF. Let us get into it. So now, HCF and LCM. Here I have taken few examples so that I can make you understand better about HCF and LCM. Now let us start with HCF. HCF of 6 and 8. Now we know that HCF is based on factors. So let us write the factors of 6 and 8. 6 factors are 1, 2, 3, 6. Now factors of 8, 1, 2, 4, 8. Now, what are factors of any number? Factors of a number are those which can divide the given number. Common factors. Now, what are the common factors here? Common factors are those numbers which can divide both the numbers. Now, in this case, these two are the common factors. Now, highest common factor. It means highest number which can divide both 6 and 8. That has to be 2. So 2 is the HCF of 6 and 8. So what you can understand, highest common factor is nothing but highest possible number which can divide both the given numbers. Now let us check with 6 and 12 and 15. Suppose if I write the factors of 12, I'll have 1, 2, 3, 4, 6 and 12. Factors of 15, 1, 3, 5, 15. So these are the factors of 15. What do we want? Common factors. Common factors are those which can divide both the numbers. Which are the common factors? We have 1 and we have 3. Agree? 1 and 3 both are the common factors because both can divide 12 and 15. Now which is the highest one among them? 3. So 3 is the highest number that can divide 12 and 15. So 3 is HCF of 12 and 15. Suppose if we deal with 9 and 15. Let us write the factors. 1, 3, 9. Here 1, 3, 5, 15. Now you should understand this. So which is the highest number that can divide both 9 and 15? Obviously it is our 3. So 3 is the highest common factor of both 9 and 15. If you talk about 5 and 10, factors of 5 are only 1, 5, whereas 10 is 1, 2, 5, 10. Now among them, common factors are 1 and 5. Which is the highest one that can divide both 5 and 10? That is only 5. So 5 is highest common factor for both 5 and 10. Let us see for 8 and 9. Factors of 8, 1, 2, 4, 8, 9, 1, 3, 9. Now, do they have any common factors? Yes, 1 is the only common factor. So 1 is the only common factor means 1 itself has to be the HCF of both 8 and 9. Now let us look at LCM. So LCM, we know it is based on multiples. What are multiples? Multiples are those which are divisible by the given number. Suppose if I write multiples of 6, what do I get? Multiples of 6 are 6, 12, 18, 24, 30, 36, 48, 54, so on. Multiples of 8, 8, 16, 24, and going further we can have 32, 40, 48, 56, so on. Now, multiples of a number are those which are divisible by given number. Now, common multiples. What do you mean by common multiples of two numbers? The numbers which are divisible by both the numbers are common multiples. In this case, we have 24 which is divisible by both 6 and 8. We can have 48. Going further, we will get 72, 96 and so on. But what do we want? Lowest common multiple. Among the common multiples, which is the lowest one? That is 24. So 24 is the LCM of both 6 and 8. Now understand. What do you mean by LCM? The smallest possible number divisible by both 6 and 8 is nothing but LCM. Now should we really write all these things? No, we can actually directly calculate. Start from the bigger number. 8, 16, 24, 32, 40, 48, 56. These are the multiples, right? Now check out. These numbers are divisible by 8. But we want a number which should be divisible by 6 as well. Is 8 divisible by 6? No. 16 divisible by 6? No. 24 divisible by 6? Yes. So 24 itself is the common multiple or least common multiple for both 6 and 8. Let us go for 12 and 15. Let me write multiples for only the bigger number, that is 15. So 15, 30, 45, 60, 75, 90, so on, right? Now check out. So in this is all these numbers are divisible by 15. Now we need a number which is also divisible by 12 among these numbers. Is 15 divisible by 12? No. 30 divisible by 12? No. 45 divisible by 12? No. 60 divisible by 12? Yes. So 60 is the smallest number divisible by 12 and 15. So 60 itself is our LCM of 12 and 15. If I go with 9 and 15, again, start writing the multiples of the biggest number. Now 15 divisible by 9? No. 30 divisible by 9? No. 45 divisible by 9? Yes. So 45 is the LCM of both 9 and 15 in this case. Now first multiple is 10. Is 10 is divisible by 5 as well? Yes, of course. So 10 itself is the LCM of both 5 and 10. Now you can go further, 10, 20, 30 and all. Doesn't matter. The very first multiple of 10 is divisible by 5 as well. Now in this case, write multiples of 9. 9, no. 18, no. 27, no. 36, no. 45, no. What else? 54, no. 63, no. 72, yes. This is the least common multiple for both 8 and 9. So what do you understand? Least common multiple of two numbers is the smallest number divisible by both the numbers. Now let us summarize this. What is HCF? HCF of two numbers is the highest number that can divide both the numbers. What is LCM? LCM is the smallest number divisible by both the numbers. Now, few observations. Now, if you see in this case, both 5 and 10, bigger number is divisible by the smaller number. In that case, smaller number itself is HCF and bigger number itself is LCM. Suppose if I take another example like 6 and 12. If you see in this case, the HCF is 6 itself and LCM is 12 itself. When is this possible? When the bigger number is divisible by the smaller number. Now if you see this 8 and 9, can I call they both are co-prime numbers? Yes, of course, because they don't have any common factors between them except 1. Now whenever the given numbers are co-prime numbers, 1 is always the HCF and product of both the numbers will always give us the LCM. Well, we have learned during the co-prime numbers, the other definition of the co-prime. What are co-prime numbers? Two numbers should not have any common factors except 1. What was the other definition I gave you? If HCF of two numbers is 1, then they are also co-prime numbers. So from this as well, we can understand that. So let us take another example. Suppose if I take 14 and 15, you can directly tell these are co-prime numbers. So HCF is 1. LCM is product of this. So that is 150 plus 60, 210. So these are few common observations. Apart from this, there is one more important observation what you have to see. Now if you see N1 and N2, I'll take HCF, LCM, N1 and N2. Okay. In this case, N1 and N2 are 6 and 8. What is 6 into 8? 48. Now, what is HCF? 2. What is LCM? 24. What is 2 into 24? 48. So, what do we get here? N1 into N2 is always equal to HCF into LCM. So, product of two numbers must always be equal to product of their HCF and LCM. Suppose if you check here, 12 into 15, 150 plus 30, 180 is the product of numbers. 3 into 60 is also 180. 15 into 9, 135. 3 into 45 is also 135. 5 into 10, N1 into N2. 5 into 10, 50. That is HCF into LCM. In this case, N1 into N2, 8 into 9, 72. In this case, 1 into 72 is also 72. It means in every case, the product of given numbers must always be equal to product of its HCF and LCM. Now you understood the complete mechanism of HCF and LCM and the various properties that we come across. Now another thing is, if you have observed the examples what I have taken, they are very small numbers. Now what if I consider the bigger numbers? Suppose if I take HCF of 36 and 54. Now it will be slightly difficult for us, because we do not know the direct, how to write the multiples of 36 and 54 because they are very big numbers, right? What we have to do. Now this is where our factorization come into picture. Now what do we do? Let me show. First, we should factorize the number 36, which is 4 into 9, which is 2 square into 3 square. Now then factorize 54. 54 is 2 into 27, 2 is 2 power 1, 27 is 3 cube. Now, to do further, you should know the very basics of your set theory. Yes, I'm talking about set theory. Let me tell you what it is. Now, HCF is all about intersection operation. LCM is all about union operation. I'm pretty sure you'll be knowing this union and intersection. Now, let us see. HCF, intersection operation, means you have to take all the common terms, common bases. Now, both 2 and 3 are common in both the numbers. So, the common basis is 2 and 3. Now, consider only the smallest powers of the numbers in both bases in both the numbers. Now, if I talk about 2, what is the smallest power of 2 in both the cases? 1. For 3, what is the smallest power? Square. So if you write it, 3 square 9, 9 into 2 is 18. 18 is the HCF of both 36 and 54. If you want cross verify, 13 into 2 is 18 into 2 is 36, 18 into 3 is 54. So 18 is the highest number that can divide both 36 and 54. Now if I talk about LCM, union operation, means consider all the bases. Now again, all the bases means here we have only 2 bases, 2 into 3. But consider highest powers. What is the highest power of 2 in both the numbers? 2 square. Highest power of 3 in both the numbers? 3 cube. 2 square is 4. 3 cube is 27. 27 into 4 is 108. So 108 is the LCM of both the numbers. Cross verify. LCM is the smallest number divisible by both 36 and 54. 36 into 3 is 108. 54 into 2 is 108. So there is no other number smaller than 108 which is divisible by both 36 and 54. Now let us consider another example. Suppose if I take some numbers like 480 and 720. Now if you want to calculate for this, what do we do? First factorize. So if I factorize 480, this is 48 into 10, and then 48 can be written as 3 into 16, and 10 can be written as 2 into 5. Now in this case, 16 is 2 power 4 and 1 more 2, that is 2 power 5 into 3 power 1 into 5 power 1 is the factorized form of 480. 720. If I factorize this, this is 72 into, let us take some other number instead of 72. If I take 820, this can be written as 82 into 10. Now what is 82? 41 into 2, and 10 is 2 into 5. I changed the number. Instead of 720, I'll be taking 820. Right? Now, if I factorize this finally, this is 2 into 2, 2 square into 5 power 1 into 41 power 1. That is the factorized form of 820, and we have the factorized form of 480 as well. Now let us calculate HCF and LCM. Intersection, union. Intersection means what? All the common bases. Which are the common bases for both the numbers? Only 2 and 5. Which power should we take? Lowest power. Lowest power of 2 is 2 and lowest power of 5 is only 1. So what is that? 2 square 4, 4 into 5, 20. So it means 20 is the highest number that can divide both 480 and 820. There is no number bigger than 20 which can divide both these numbers. So HCF for 480 and 820 is 20. If we talk about LCM, what happens? All the bases. What all the bases we have? 2, 3, 5 and 41. Now what do? We will take the highest powers of the bases. Highest power of 2 in both the numbers is 5. Highest power of 3 is 3 only. And highest power of 5 in both the numbers is 1 only. So if we do this multiplication, 32 into 5 is 160 into 3 into 41 is 123. So if I multiply this further, 1600 plus 120, 1600 plus 320, that is 1920 plus 48. 1920 plus 48, 1968. One extra 0. This must be the LCM of both 480 and 820. Now let us generalize how to calculate HCF and LCM for bigger numbers. Suppose if I take two numbers something like this, n1 that is equals to, let's say, a square into b power 4 into c cube into d power 5. I'll consider another number, let's say n2. Let me write here itself, n2 is equals to, if I take c square or c power 4, I'll take into d cube into e square into f cube. These are the two numbers. So now let us calculate our HCF and LCM for these numbers. Now we know HCF can be calculated using intersection operation, LCM can be calculated using union operation. Now starting with HCF, intersection, common basis. Which are the common basis for both the numbers? Only C and D. So I'll take C and D. Which powers should we take? Lowest power. Lowest power of C in both the numbers is 3 and D is also 3. C cube into D cube is our HCF of both the given numbers. Now LCM. LCM, which basis we take? We should take all the bases. So what are the different bases we have? A, B, C, D, E and F. Right? If you write the powers, which powers? Highest power. Highest power of A is A square only, B is B power 4 only. C, what is the highest power among these two? 4. D, highest power 5. E, highest power is only 2. F is 3. Now this is our LCM. So this is how we can calculate HCF and LCM of bigger numbers by factorizing and then using union and intersection operation. Now, whatever we have seen in this case is all about learning how to calculate the HCF and LCM. Well, there won't be questions every time or a direct questions on HCF and LCM. Rather, HCF and LCM will be a part of the question. And there will be few questions or something like, putting a different plants on different rows. How many maximum plants can be planted and how many minimum plants can be planted. Or you can have questions based on different bells ringing together. Well, there will be many questions which are based on HCF and LCM, which we will be seeing in our advanced level of number system. To watch more free videos, download our LOL application from Play Stores. If you are benefited by these videos, please like and share our videos. And also do not forget to subscribe to our YouTube channel so that you don't miss any of our new videos that we upload regularly. If you have any queries or suggestions, please drop them in the comment section below. Also, if you want to reach out to me or any of my team members, you can always do that through any of the social media platforms, and the links of which are already provided in the description below.